Okay, I just want to talk to you guys today about speeding up chemical reactions, things that we can do to make a reaction go more quickly, or even just why do some reactions happen, some don't. So in order for there to be a reaction, what do you think has to happen? There needs to be collisions. So you can see like here, this little animation, we've got A, B, and C are the reactants, and then the product is that purple blob. So they have to collide. That's one criteria. And the other thing is that they have to collide with the right orientation. So in this picture, you can see these are the two reactants. This is O3 and this is NO. And they can hit each other possibly, but maybe not be at the right angle. Um, so they just fall apart. Here, they did happen to hit at the right orientation with enough energy, so then they form the product. So here's just another animation. There's a collision where it wasn't enough energy and they weren't going fast enough really to hit each other and to form product. Whereas, let me see, this one is going to result in the reaction. Here's another animation. You can see that sometimes they bump into each other, but only if they hit right and with the correct amount of energy do they actually hook together and form the product. So take notes on this. So collision theory is the circumstances that we have to have for a reaction to occur. So the reactants have to be able to find each other and collide with each other. And they have to be at the right orientation, so at the right angle when they hit each other. And then they also have to have enough energy. So if they hit each other with the correct angle but don't have the energy, they won't form product either. So they have to hit each other at the right angle and with the minimal amount of energy. So really only a small number of collisions are going to meet the requirements and actually result in the reaction. Here's a diagram that is in your textbook. It's looks a little weird at first, but let's talk about it. So this is showing you, and I would sketch this in your notes. The x-axis is the reaction proceeding, from reactant over here to product over here. And then energy is the y-axis. So you have your reactants, the blue and the green, and then they have to hit each other at the correct angle. And what happens is that there's a minimal amount of energy needed, to get them to collide and hit each other. This is called the activation energy. So this is that when they hit each other with the right orientation and then also with the correct amount of energy. They form this kind of in between called a transition state where it's not really like the reactant and it's not quite the product. It's in between. If you need to form this, if you don't form this, there's no chance of forming products. So then this will kind of, be just for fractions of a second. Then it'll then possibly form the products. Catalysts. So catalysts can somehow, they speed up the reaction, but they're not actually a reactant or a product, so they can keep being used over and over. So catalysts sometimes just allow kind of an area for the reactants to find each other. Enzymes, you probably remember from biology, these are proteins that are biological catalysts. So enzymes are just one type of catalyst. So a catalyst is anything that speeds up the reaction and then without being used up. So you can see over here, the green thing is the catalyst, and then it's helping the blue and the red reactants to find each other. So if you go back to your diagram that we made with the energy and the reaction progress or on the x-axis, a catalyst will just lower this curve. So it takes less activation energy to be able to form that kind of in-between transition state to then form the products. So more collisions are going to have enough or the appropriate amount of energy to form product when you use a catalyst.